Okay, so I've opened up the Epic Games launcher here. You can find it if you go search for Epic Games if you haven't already downloaded this. Um, I'd suggest you do so. They're putting out games for free. You can click on this link here to get the launcher. Certainly fun to play games, but try not to get distracted in between your class. It's sort of the unfortunate side of having games tied to your development media, but we'll try to stay focused here. So you've got another number of options in terms of after you've installed it to click through and go to the store, go to your library. You want to stick to Unreal Engine down here, and if you go to the library for your Unreal Engine, it'll show you your projects, which I've got several here showing, and I've got several versions of the engine downloaded. If you don't already have one downloaded, which you probably don't if you just installed the Epic Launcher, click this button here and add in a new version, right? And so you will see at least one version that way, and then you can click to either update or install or whatever you need to do. You probably only want to install one unless you have a lot of disk space. It's pretty large, and all of your projects are going to be large too. So try to stay focused on one. The precise version that you get doesn't matter too much. Make sure it's a 4 point something version, probably a 4.24 or 4.25. We'll probably spend most of the class on 4.24, but the differences between the versions aren't going to be too substantial unless we get into like version 5, which is a pretty substantial difference at this point. Okay, so I'm going to launch 4.24, and we'll start taking a look at what it looks like. Okay, so this is what happens after we open up the Unreal browser. You see a few games available, some previous stuff that other people have worked on that I've got here. But of course we want to make our own one and not a previous class's assignment. So we'll go to Games, because we're going to create a game. And we'll click Next, and then we see a number of options here. And what we're going to do is focus on the first-person shooter for the first part of class. So we'll go ahead and click on the template here to create a first-person shooter. You can obviously explore some of the other templates if you're interested in what they do, but we're gonna, for the first assignment and for for a couple weeks here, we'll be looking at just this first-person shooter version. So we'll click Next on that. We're gonna create all Blueprint classes. We'll go ahead and keep it with maximum quality and so on. And then down here, I've located all my Unreal projects on my D drive, and then I'm going to create my first FPS project. You are welcome to create whatever name you want there. And what we'll find when this is created is that it's actually created it on disk in the location that we were looking at, right? So in my case it was the D drive. So go look at my D drive and see that under Unreal Projects I have my first FPS here, right? And that's the one that exists that I'm looking at and that I want to walk through. Okay, and we'll be able to see some of the content that's stored and look at it back and forth between the two as we go through this. So through the magic of video editing, we now have our project up. Yours probably took a little bit longer to load. That is totally fine. I'm skipping ahead in time. My computer isn't instantaneously fast. So we have the template. Let's go ahead and press play and just see what's available. You'll notice that there's quite a bit of sort of gameplay available. If you've not played a first-person shooter before, then you want to use the W, A, S, and D keys to move you around. So W is forward, S is back, A and D move you left and right. And then the mouse aims our vision. So let me press play and you can see how that looks. So when I click on this, and clicking shoots, so my mouse is moving around my view. Apologies for the disorientation there. W moves me forward, S moves me backwards, A and D move me left and right. And you can play around in this space and see what's possible. You can look that the bullets tend to move pretty slowly, but we have quite a bit of sort of gameplay already available, right? There's no, I wouldn't call it a game, right? No, but there's a few mechanics that are there for us to work with, some pretty nice visuals even, considering it's black and white. But this is what we'll start with and kind of work through this for our first project. Okay, so let's continue looking at really the interface here. So we'll start by looking at the main view. Incidentally, you actually control this main view very similarly to the way you control the first-person shooter. You use WASD to move around. I'm holding right-click to do this, though. So by holding right-click, I can move my mouse around, and then I can use WASD to maneuver through the space. So this makes it very easy to kind of fly through your game space and understand where you are in that space and find the things you need to find. So that's certainly a way to do it. You can also double click to find an asset, to see it. It depends on what you're doing in terms of whether that's easier or not. Sometimes you get a lot of assets over here. But this is our world outliner that shows us essentially everything that's in the world here, right? And so we see, you know, a specific view of where our camera is, but it's useful to understand what we have going into our entire environment. And so that's what the world outliner gives us. It's essentially everything that's in the world at any time, and just by name listed down. So in some cases, especially when you start with a large project like this one, you don't know which one Cube 15 is, and it's not on the screen here, and so it's hard to keep track of. Good note to, you know, maybe think about naming your things usefully. You can name it the east wall, the west wall, the entry wall, the lobby wall. But it's a good idea to name things usefully so that when you're clicking over here, you know what you're looking at. But of course, when you get enough walls, it becomes hard to name them in some useful way, potentially by region breakdowns or something. So sometimes it's easier just to be able to click on the view to find the object that you want, right? So if I'm looking at this cube, I want to know what that cube is. I don't really care that it's called Cube 14. But between the two, you kind of have the option to either find your objects in the main scene view here, or to use your world outliner to find the object that you're trying to figure out where it is in the world, especially if it's something very important like your first-person character, and that one certainly is an easy one to look for. Another button that another maneuver I'm doing here. This is the middle mouse click, and this lets me pan within my existing zoom. And of course, I didn't actually mention it, but I'm using left click kind of as the primary method. So hopefully, everyone taking this class is fairly confident with things like moving a mouse around a screen and left clicking. But if not, then certainly post questions as we move through and make sure that those things all become clear. Okay, so let's kind of take a look at the various buttons we have over here for really just editing our environment. So although there's some editing that can be done in terms of where we have our objects in the world outliner here, a lot of the things that we're going to do in terms of setting up our world happen in this main view, the viewport right here. We can have multiple viewports, but of course we start with this default one, and we'll live there for a while. As you get more comfortable with things, you can explore adding new viewports and having multiple viewports open. So you'll notice that we get these arrows whenever I left click one of these objects that lets us move the object along the axis that we see, right? So we're moving along the red axis, the green axis, and the blue axis, and you can see that these correspond down here to our location, right? And so we see that we're highlighted on this cube, editor cube number 11. We see my location is listed with, you know, these large numbers here that maybe don't mean anything to me, but I do know that I see the x value decreasing as I change the red. So x is sort of our forward backward axis, y is our left to right axis, right? We see that one changing here, and you of course hopefully are seeing the color correspondence here. So red corresponds to x, green corresponds to y, and z is our up and down, right? And so we do have two options. We can, if we want to get a very precise number, we can say I'm going to edit this field and click to 100 and put my object right there at 100, and I'm going to make sure it's 100 on the y as well, and I want to make sure it's at 264 on the z. Actually, I don't know what the floor would be. Looks like the floor for some reason is at a height of 244 centimeters, which is strange, but there you go. And so we can edit the values here, but we can also drag and move them around over here. And maybe additionally usefully, there are these small squares that we can grab that let us move along a plane. And so probably the most useful one is this, which lets you stay along the ground floor without elevating your object at all, right? So you'll notice that my Z value doesn't change, but my X and Y value do. And so when you're moving in 3D, you sometimes move an object. So if I were to just grab this object and start moving it, it moves in all 3 dimensions at the same time, depending on where I'm looking. That's really not useful ever, unless you're just trying to move very quickly. Often you want to either move in only one axis or 2 axes at the same time in order to, say, make sure that you're on the ground, or to move somewhere on the ground to a space you care about. So it's worth kind of getting used to moving with these, moving with an axis, moving in 3D space, and understanding the relationship of your camera to the object, and especially the object to the world, right? And how you're moving through the world that way. Okay, so that is our transitional transformation on the location. But let's look at the next one. So we can also rotate, and what we see here is a similar color correspondence. What this means is that we're rotating around that axis, right? And so if you, and this is currently in global space, so it doesn't care that the object itself is kind of rotated off. We're using the global value for the y-axis here. And the idea is that your rotation is around an axis. So you can imagine having sort of it's almost like an axle to a wheel, right? The wheel is going to spin around the axle, and the axle is the long pole, the axis that we're going to spin around. And so in this case, I'm spinning around the y, whereas previously I could move along the y by grabbing the green arrow here and moving. But when I'm spinning around the y, I'm spinning sort of perpendicular to that, right? And I'm spinning my object perpendicular to that y-axis in that way. And of course this corresponds to the next set of rotations down here, which are what are known as Euler angles for the rotation itself. Really the reference to Euler angles, there's a mathematician named Euler. You don't necessarily need to worry too much about why they might be called that, only that you're dividing, it's a way of dividing your rotation up into the 3 axes of rotation, as we see here. Right? So you might be wondering, can I rotate my box around its own space, right? So I've got this sort of weird situation where I'm kind of off kilter, and you can, there's this icon here that lets us switch between object local transformations and global transformations. So you'll notice that both the arrows and the rotations are now focused on the direction our object is going. So if we look carefully, we see that this y-axis is now corresponding to the y-axis of the box, or the x-axis of the box here. Or of course the z-axis in this case is the same. And what you see here too is that the box is now, or the translational arrows are also doing the same thing. So we can translate in the direction of the box. This can be incredibly useful for when you want to move something in the direction it's already facing, right? So if you want to move your character forward a little bit with like the FPS controller, you probably want to be in character local space, because then if you've happened to say rotate, let's rotate my character a little bit so he's kind of off angle. I want to do, you're seeing yet another way of rotating this. I'm grabbing until I see these little arrows down here, and then I rotate by clicking and dragging. So let's say my character is a little off axis. If I want to move in the direction the camera is facing, that's difficult to do right now because my red arrow is going that way. So I could try to grab this little icon and move it, and that's fine. However, if I switch to the object local view, now I can go in exactly the right direction. So I can grab the x-axis directly and move forward in the character's local forward frame. So this is a very useful way to be able to edit the objects and move them in sort of a natural case. Okay, so that's this icon here that lets you switch between global and local space. And then of course we have our rotation and translation work in both. And the last one I'll show you is of course scale, which is kind of the last major modifier that we would use. And so that one lets us resize our boxes, and this of course is a great way to start building shapes into your level. So if I want to say create some wall shapes, I might take a standard cube like this and scale it and rotate it and shift it in order to build up some walls, much like we see over here, which is probably how these walls were built, although they may have been constructed in some 3D modeling tool as well. For whatever reason they might have been done that way. Um, okay, so yeah, again we're modifying the scale, and again we can also modify this scale over here by modifying the values, or we can just look at the way those values are being modified. You'll notice that scale is kind of always relative to the object itself. That's probably because it doesn't make sense that you would ever scale the object off some random angle and end up skewing and reshaping the object, and that's probably never what you'd want. And then finally, the last point here, before we move on to sort of the next few things, there are keyboard shortcuts, and so you can kind of do the two-handed rule the whole time, where you kind of keep your left hand on the left side of the keyboard, and it's WER that switches between each of these keys. So you see me typing WER and swapping between these modes. So when you're doing a lot of editing, you'll probably find that being able to keep your left hand on the keyboard and your right hand on the mouse and move the objects around in this very natural way is very useful when you start creating complicated scenes. Oh, there is one more thing I wanted to mention before we move on completely from here, and that is the ability to snap to the surface. So we can snap to both the positional values. So right now you see us transitioning at 10 units, and that's because of this 10 here. And if I take that off, I'm suddenly transitioning at very precise floating point values, right? And so it allows me to be very precise in my movement, but it's very hard to line things up when you don't have it snapping to a grid, right? So if I wanted to actually make, say, two objects or these objects over here line up in a specific way, if I don't have the grid, then you have to be very careful about the way you set them, and it can be challenging. It's especially interesting with the rotation. So by default we have a 10-degree rotation, which of course makes it very easy to kind of make it line up to a certain angle that we want. But you can switch that by switching off the snap here, and so if I switch that off, I'm now able to move to very precise degrees, which is probably more useful when it comes to rotations, but again, probably not as useful when you're trying to line things up. But these two flags will let you pick those options as you go. Alright, so let's move on and look at some of the other views here. We'll spend a few more minutes looking at the world outliner here. There's not a whole lot of extra detail that we're going to care about in terms of the objects. The one other piece that's useful is to know that that you can create these folders much as you're seeing here. And this is a good way, as we already talked about, editing these scenes to control the complexity that you're going to get with these scenes. So we see that, for instance, the arena, all the arena objects are stored under here, and so we can hide those. We can look at all the cubes that are specific to moving around within the scene, and those are here, and we can hide the various areas that we don't want to look at, which makes it useful when you're editing a complicated scene to just sort of focus on the one piece that you care about or the one area that you might be looking at. So certainly use that to help you keep yourself organized. Down here below that we see the details view, and this shows us a lot of the pieces that we can edit on a particular actor, right? So everything, really almost everything that we're seeing up here, with some exceptions, are actors which have a position, can store components, and have sort of the capability to be displayed out here. So we also see an actor to the left over here, and that's kind of the bottom level. There's a lot of documentation assigned with it. That's sort of the bottom level object that we might get in a scene at any time. So it has things like our transform and the rendering capability. In this case, this actor doesn't even really have anything else associated with it because it's just an empty actor. But we could attach a mesh to it. We could just attach some scripts to it. But it's kind of the base default. And then the next level up is a character, and a character then is something that has a mesh, probably is moving around, might have navigation associated with it, and we probably have some AI or something. Or we have a pawn, which is actually controllable and can either become possessed by the player or possessed by the AI, and in that case we're actually doing a control. So all of the characters that we're controlling are pawns. But a lot of the things that we see in the realm, like the cubes here or the walls even, are actors at some level. So if we were to go look at, say, the details of our first-person character here, if we scroll down, we'd see a lot of the components that are attached. I think somewhere in here we'd see the pawn, but we can also just see that by editing the first-person character over here. So we're actually, so this is our sort of our first view at looking at a template. A blueprint. A blueprint is kind of a template pattern. That is, you create the style of the thing you want to modify, and then you create many copies of it, right? So a template in real life is sort of a pattern that you then copy over and over again, and the same thing is happening here. So we've got this first-person character. It's a character. It's a pawn. We see the reference to the pawn control here. We see a lot of other details that are associated with the fact that it's a pawn. We will talk about inheritance, but this also represents an inheritance of hierarchy, where the character is kind of the base level. The actor is the base level. The character inherits from actor and adds a new capability on top of that, and then the pawn adds new capabilities on top of that. And so that's what we see to the left here when we're clicked on just our first-person character. But we also see a lot of these other components that are added to it. And so the components then add extra capability beyond just the base level that gives us the character and all of these sorts of settings over here. So you can think of this whole system as a set of actors and a set of components that get added to those actors. And this is, if you're familiar with Unity or you've worked in other systems that do game development, it's often the case that you will have some kind of base character or some kind of base object. In Unity, it's referred to as a game object, and then you add components there. But it's a very similar kind of feel where we really have some self-contained capabilities that we want to add to each object, but we kind of start with the base object, and then we add the capabilities to that. So that's what we're browsing here. In some cases, we can see some of those capabilities exposed at this top level from the world outliner, but it depends, and it depends on what's been chosen to be exposed and how we move through the world. But that is often what you see in the details view over here. Primarily, what we'll use this for is the chance that we have to modify the transform, and then we'll also in some cases see some variables that we might modify. So we see some of the variables here, things like the mass mode or the uniform mass, say with the clothing, or things about the physics, especially when we start talking about physics. But when we do our own blueprints, we'll be able to define variables that then we'll attach and expose at this level and be able to edit those as well. So the main points here are one, that we're collecting a whole set of objects as we've seen in our scene. We can look at the details of those objects, and those all get inherited from the actor as kind of the base object that we're dealing with, or a character or a pawn. Okay, so before we move off of these views, let's look at just a little bit more in the modes view here. So there's several modes. We'll probably spend quite a bit of time in the placement mode, which is where we would use, find some things like lights and some of the volumes, which we'll see later on. But in particular, this basic set not only includes the empty actor and character and pawn, but it also includes some nice defaults that we might want to play with, particularly the cube. So, we already saw the fact that we could take a cube like this and squish it down and make it look sort of like a wall and position it in the world. And of course, if we want more cubes, because we don't want to just have to move one cube or whatever they gave us, we can drag from this mode over here into the scene and pull new objects continually. So we can create a whole bunch of new cubes. These, of course, are very default kind of characters. So it's yet again the actor object. In this case, it's really just a straight actor object with a static mesh component attached to it. So there's no difference between this. So it's not inherited from the actor. It actually is an actor. It just happens to have a static mesh component defined for it. So this is the idea behind, say, a template versus a class instance. A class instance would just say, give me a new copy of an actor, whereas a template says, well, I want to be an actor, but I also want a certain set of components by default attached to me. And so here are the set of components, and maybe even here are the values that I want on those components, which of course we can do as well. So that's pulling the cube over, and this is of course is how you're going to do this to build your level. There are other modes here, and we'll probably get into some of these later in the semester, especially the landscaping and maybe the geometry editing as well. But for the most part, what we're worried about is either pulling objects from the scene down here, which is another way to do that, or that we've imported, or just simply creating things out of cubes, which of course is sufficient for a lot of cases. Cubes and spheres and cylinders and so on, and maybe planes as well. Okay, so we've gone that far, but let's take a look at how we might create our own blueprint. So we've got a cube in the scene, and it's fine if all we care about is the fact that we want to just have the cube and just have maybe some shapes to it, right? We're just creating walls. But what if we actually wanted to start adding capabilities? We wanted to add new scripts. We wanted to add new gameplay behaviors. We wanted this cube to become a door, and then we wanted to use the door in multiple places. Well, in that case, we need that cube to become a blueprint. And so by doing that, we then go in and tell it we're going to create a blueprint. So I'm just going to create a blueprint of this top level content directory, and it's going to name it the cube blueprint here. And so the blueprint kind of exists as two things. One, it's the reference to the scripting language, which we'll go into plenty of detail over the course of this semester. But it's also the fact that blueprint means a template, right? So if you have a blueprint of a house, you can follow the instructions on that blueprint house and build an instance of the house, build a copy of the house with all the things that you're supposed to have, all the walls in the right place. Again, you might think of this as you're not building an instance of a class. You are building an instance of a house, but the particular configuration of this house is based on the blueprint that you're using, right? And so that's maybe a little bit of the difference, and we'll go into more detail on this when we talk about the way these things are architected. So the blueprint is kind of a zoomed-in view of a particular object, right? So we can see all of the objects in our world show up in the world outliner, and we can see some of the details show up over here, and we can take a look at some of those details and modify some of them. But really, when we're in the blueprint, we're focused on the one object that we're talking about, the one object that we care about. And we have many aspects of that object that we can modify. The two main things that we want to modify are probably the appearance and then the components. And potentially we are adding components as part of either adding capabilities, or we're adding code as part of that. So the code really ends up being attached to the top level object here. But there's maybe some code that's attached or available as part of adding the components as well, especially in terms of creating new events for us. So this is the blueprint scripting language, and what you see is a series of blocks that represent essentially entry-level nodes or entry nodes into a script, right? We have the block itself, which is red and means that it's being sparked by an event. So you can see, obviously, this one is when the game starts, when we begin playing the game. Actor begin overlap is whenever you start overlapping with some other actor in terms of a collision event, and so you would have that to let you know that you ran into somebody, or maybe you bumped into a door, or you stepped on a pressure plate and you're supposed to open a door somewhere else. And then event tick has to do with when the game, every time the game engine loops, and if you've heard the term FPS, that's frames per second, so that's actually usually tied to the number of simulation loops in the game engine. And so if we have an FPS of 60, that means that this event tick is going to be called 60 times. And so we can do updates that are supposed to happen over time by tying to the event tick. There are, of course, other events. One of the other big ones that we'll see is the ability to get input as events. And so we can define keys as input events like move left, move right, which of course they've already been for this FPS player, and we can tie to those and be able to create scripts out of that. So in fact, let's take a look at the first-person player, not to get too overwhelmed. We'll just kind of look at the way one of these complicated blueprint scripts gets built, and then we'll start breaking it down as we go and understand more about, especially how the first-person character looks and all of that. So what you see are sort of two sets of lines. There are some white lines and some colored lines. And so the white lines represent flow of execution. So that means if I do get an input axis, where in this case I'm turning, then I can follow the white line to figure out, well, okay, if I've got this event, then here's the next thing that's going to happen. And it's going to change some input on the pawn, right? It's going to rotate in the yaw If you're not familiar with yaw, pitch, and roll, yaw is kind of turning left and turning right. So really, this is our left and right turn right here, and this is the input axis that's tied to that. And we'll look at the input axis later. We'll just not worry about it for now. You'll see that there's also the look up here, which is pitch. So we've got yaw and pitch. With a first-person controller, you don't usually roll, unless, of course, you've got some special capability to, say, dodge to the left or right or something. The green lines here represent values. So the green, in this case, is a floating point value. And what we're getting is a floating point value that represents how much of either to the left or the right we're moving. So +1 to the right, -1 to the left, and 0 if we're not turning at all. And then we multiply these things together, so we have this multiplication node here. And then that outputs the value here. Now you'll notice that there's not really execution lines here. This is just the flow of data. And so what happens is we follow this white line here that says I've pressed a button that should start turning. And so I need to go over here and look at that. And that says, well, I've got this green pin, and I need to understand what data I'm getting out of that. So I'm going to go almost backwards. So I've moved to this node for execution, and I'm going to move backwards and say, okay, what data do I need out of the multiplication? Well, I don't know yet because I've got 3 pins here, so I need to go query those. And I can follow this pin and say, well, okay, what's my current axis value? What's the base turn rate? And the base turn rate is a variable that we have over here, so we've defined it and we've given it a default value of 45. And then the world delta seconds says how quickly are we updating. So again, if we're referring to frames per second, this is, and we're getting 60 frames per second, then the world delta seconds is 1/60, or about 16 milliseconds. And we'll talk more about this, but that helps us scale the rate of things into an actual rate, right? So what we're saying is turn at some number of radians per second. And so given that, and actually I think it's degrees per second because we're using 45 as our base. So we move it something like 45 degrees per second to the left or right, and we move based on how much that value is, and then we multiply all those values together and they flow this way, right? So again, we'll kind of see the flow of execution move along these white lines, but then the flow of data goes backwards as we're querying so that we can fill in the value we need. We don't need to query this target because there's no pin associated with it, and by default it gets the value of self, which is us, right? And so what that means is I'm going to figure out when my node is needing to be executed by following the white line, what my turn value is by querying the green lines and figuring out, all the math that needs to happen to make that happen. And so, let's say for this instance, we're going to move around 45 degrees divided by 60, or 1/60th of 45 degrees, because of course we're only moving for one frame. We apply that amount of turn, and then we move on, right? And this happens all over the place. So we have, that's just one instance of where we're trying to turn. We have the begin play up here, which does a few different initialization kinds of things, depending on whether or not we have a VR setup, and a number of things in here. And then we have maybe our move forward is another interesting one. This is when we're pressing W or D, and we see the same kind of thing. We see an execution line. In this case, we see 2 lines. One is the green line that says how far should we be moving forward. In that case, we're just either going to be moving forward at 1 or moving backward at 1. And then we get this forward vector that says, where do we want to move, right? So because this is moving us in the world, in this case it's trying to figure out where we're facing, and it's going to move us in the direction we're facing, which is of course what we want, rather than, say, the world axis. In fact, I'll remind you, we already kind of saw that in one instance where when we were turning this guy, we cared about whether we were in the local frame, the local axis, or the world axis. And so what that code is doing almost literally is the same kind of thing. It's saying, given that we're not facing the world direction, we don't want to necessarily move in positive x, which would be this way, right, where the red line is moving in the world axis. It wants to figure out where our camera is facing and move us forward in that direction, which is what we would expect from this code. And so that's where this code is coming from. Don't worry too much about the complexity right now. Just understand that we can get the forward vector, we can get the active forward vector, we can apply these things, and we can plug them in and say, this is the direction I want to move, and this is how much I want to scale. That is going to wrap up our time with looking at the introduction to Unreal here. You should now take your time to Make sure that you have Unreal installed, that you can load this up, that you can start the first person project itself, and then make sure you can browse through, open up the first person character, get to the initial map and take a look at everything. If you feel like exploring even further, you could take a look at the settings and look at things like the project settings here and the input. We will come back to this, of course, but this is things that we haven't talked about, but this is where you define those kinds of things. There's also a world settings, which defines, I'll set it here, a lot of the variables that sort of initialize the game in the first place, right? The fact that we're going to have a first-person character and that we're going to have this first-person game mode. So these are things you can explore, but certainly take a look at, download this, get this project started, take a look at the first-person blueprint, maybe see if you can create a blueprint. I would also familiarize yourself with just moving around the scene view and trying to create a little bit of a level by moving some blocks around so that you have some familiarity with what you're doing here.